Hi, everyone, and welcome to this online talk, How to Write Great Kafka Connectors. Confluent has delivered a few talks on Kafka Connect and how to build connectors. So this time we've invited one of our partners, HashedIn, to talk about how they do it and to share their experiences. Now, before we get started, I want to cover some housekeeping notes. The console you're looking at can be fully customized, so feel free to move windows around or resize them to your liking. We've also added some buttons on the menu bar at the bottom, and I'll review those quickly from left to right. The media player lets you control the volume throughout the presentation. Next is the slide window, which you can minimize or resize. The Q&A panel allows you to submit your questions throughout the talk at any time. We've also included a resource list. This is where you can access the URLs that we mentioned throughout the presentation and other complementary content. For more information on our speaker, check out the speaker bio. And last, the question icon will open a brief survey. Would love your feedback on this talk, and more importantly, what content you'd like to see from us in the future. This session will be just short of an hour long. It will be recorded and available on demand for your review at the same URL, or search online-talks on confluent.io for all of our talks. Next, I would like to introduce our guest speaker, HashedIn. HashedIn Technologies is a software development company that builds deep technical SaaS products and platforms. They are experts in analytics, machine learning, and integrations, building on learnings and frameworks from a decade of launching over 200 products. And next, I'd like to introduce our speaker today. We are very pleased and honored to have as our guest Fahad Sheikh, tech lead at HashedIn. He delivers Kafka connectors and supports existing connectors. Should there be any questions specific to Confluent, we have Jeff Bean, partner solution architect at Confluent, on the call today. Take a look at their bios for further information. And with that, I'll turn it over to Fahad. Fahad?
Thanks, Lisa. Hello, everyone. Hope you guys are doing great. And I'm sure everyone over here knows about Apache Kafka and what amazing things we can achieve with it, be it for stream processing, event sourcing, log aggregation, and application monitoring, or things like brokering messages. Industry has been using Apache Kafka with all types of systems, such as databases, be it SQL or NoSQL, messaging queues, data lakes, and data warehouses, moving data in and out of these systems, and building cool applications around it. In today's session, we are going to talk particularly about Kafka Connect, an open source component of Apache Kafka, rather a framework that helps us simplify and automate the complex data integrations with different external systems by writing connector plugins, and discuss some of these best practices of building these connectors. So let's begin. So there are a couple of ways in which we can move data in and out of Kafka. One of them is to write producer and consumer applications, and I bet this is the most common one. So producer application is supposed to pull data from external systems and write it to Kafka topic using producer API. Likewise, the consumer application consumes data or records from one or more Kafka topics and structures them according to the target system, and then finally writes to it. It seems to be pretty straightforward, but there are a few challenges with this approach. How to handle failures and restarts, how do we scale the application, how do we capture metrics, and how to properly configure producer and consumer APIs. So Kafka Connect helps us overcome all these challenges and takes care of most of them, allowing us to focus on getting the data in and out of externals, making it simpler for us to write high quality, reliable, robust, and high performance connector plugins. And when combined with Kafka and stream processing framework, Kafka Connect can very well serve as a core component of ETL pipelines. So we can either deploy Connect as a standalone process that runs jobs on a single machine for use cases like collecting logs and metrics, or as a distributed, scalable, fault-tolerant service supporting the entire organization's data pipeline. So when we talk about Connect, it essentially comprises of three major components: the connectors, SMTs, and converters. Connectors are supposed to pull and push data from the external system. SMTs are used to apply transformations on the fly, and converters are for serializing and deserializing the incoming and outgoing data, depending on the format it is in. So if you look at this example, we can see how multiple connectors can work together to solve so many different problems. We have our MySQL and Postgres database servers in which the application data lies. Now we can just set up the connect and plug in our connectors. In this case, we are using the BZM change data capture connectors for respective DBs and move all the data into the Kafka topics. When that is being done, on the other side, we can start consuming these records from the Kafka topics and process them to the other target systems, such as Elasticsearch, data warehouse like Redshift, or graph-based database like Neo4j for running some complex queries or graph analysis. Of course, all of this will also be done using connectors. So this is how the Connect framework looks like. So Connect actually runs as a cluster. That means we can have more worker nodes running that are responsible for moving data between Kafka topics and connector tasks. These tasks are nothing but worker threads that talk to the external system for pulling and pushing data to them. So when we start the connector with defined configurations, the configuration gets stored in Kafka. The connector then runs some pretext and distributes the work between the tasks. Post that, connector tasks are started on each worker node, and the flow of the data begins. Oh, great. Finally, some code-related stuff. So to implement a connector, we have to mainly implement the following three classes: the connector class, the configuration class, and the task class. Depending on the connector, whether it's the source or sink connector, the implementation will change accordingly. One good thing about implementing the connector is that we can simply run a Maven archetype command, which is already available in Confluent documentation, to generate the scaffold code that you're looking at the right-hand side of the screen. So we can straight away quickly jump in and start writing our own connector. When we run this command, we might have to provide some group ID or artifact ID for the Maven project. And when it's complete, we get a project structure that looks something like this. So let's see how to implement connector. The first class that we have to implement is the connector class. And these are the following methods that we should implement. In the start method, essentially what we do is that we talk to the external system and fetch the information about the data that we are dealing with, and use information for task distribution. And secondly, determining the task level configurations. In the task configs class, the method, we receive the number of tasks that we have to run. And based on that number, we divide the work and delegate it to the different tasks by defining these configs and returning them as a list. Each task will then get their own task level configs when each of the tasks gets started. Stop method is just to make sure that we clean up all the required resources that we have opened and then that are required while the connector is running. We can close all the connection objects and open streams, sockets, and threads that were opened while the connector was running. Implementing a source connector task. To implement this, for the connector, we simply need to implement the following methods. The start method. In start, we read previously committed offsets using the source task context by accessing the offset storage reader and configure the external system client accordingly. We can start reading records from the previously left position. So what we do over here is we just access the source task context object. Within that, we can get hold of offset storage reader, and with that we can get each of the offset for the topic partitions, and we can configure the source system client accordingly so as to continue from the same position we left. We can also create all the necessary resources connections, queues and buffers that are required to pull data from the external system. In case of pull method, this is where we pull records from the external system and transform them to the source records and return them to the Kafka Connect, which in turn writes them to the respective topics. If no records are received from the external system, then we should just return null. Implementing a sync task class is slightly different. We mostly do the same in the start method. We configure the clients, create connection objects, buffer and queues that are required to push records to the external system. So the Kafka consumer by default starts reading the topic partitions from the offsets committed by Kafka Connect. To override this behavior, we can choose to read offsets from the external system, be it a file or a database table, and set the task context with the desired offsets. The connector will then start reading from that position, and all of this can be done in the open method. Put method is where the Kafka Connect makes the records in the topic available to the connector. We just need to transform them according to the external system and finally write them. We can choose to directly write records to the external system, preferably in batches, or buffer them to our max number before writing. To increase this will help us increase the throughput and reduce the amount of network calls. By default, Kafka Connect commits all the messages that were received in the put call. To override this behavior and only commit records that were actually written to the external system, we can implement pre-commit method. This method is periodically called, and the default is, I believe, 60 seconds or so, which we can simply change by tweaking the config, that is offset / interval ms at the worker level to a desired value. What we receive as an input to this method, the pre-commit method, is the latest offsets of the record per topic partition that were processed by the last put call. Instead of returning this map, we can maintain our own offsets per topic partition and return them from this hook. This way, we avoid skipping any records that were not successfully written to the external system. This comes in handy in the situations where we maintain multiple batches that were supposed to be written to the external system, or we are waiting for the acknowledgement from the external system whether the write operations were processed successfully or not. So these are some of the considerations that I want to mention when we start designing or building a connector. We'll discuss each of them in the upcoming slides. So making a connector configurable. Connectors are meant to be configuration driven. What I mean is that we should allow users to give inputs that govern the behavior of the connector, be it the connection related information for establishing connection with the external system, or the way we process and format data and deal with it. Also, it's recommended to make use of recommenders and validators that help users in providing the input and also validate them. If in case the inputs are not valid, then we should give users precise feedback to correct the inputs. We should also fail the connector if the inputs are not valid, rather than establishing connections and occupying unnecessary resources. Documentation for each of the configs should be precise, and it should be good. And it's good to have examples as well. For fields having sensitive data, we should expose them. We should not expose them in logs, and we achieve this by simply defining the type of the field as password. We should strive for adding multiple task support in our connector, which can run in parallel and carry out data exchange at high speeds. For that, we should figure out how we can distribute and delegate work to these tasks. Let's take an example of a database. If we are supposed to pull or push data, we can actually assign separate tables to each of the tasks, irrespective of the fact that we are reading from it or writing data to these tables. Ideally, the number of tasks running should be equal to the number of topic partitions that we're dealing with in case of sync connectors. Similarly, we can do the same for source connectors, depending on how we can partition and access the data from the source systems. And accordingly, we can spun up those many number of tasks. To address changes in the external system, let's suppose a table was added on the fly after we started the connector, we can actually monitor these changes and request for a retask configuration, so that even newly added tables can be processed by the connector. So as to implement this, we can actually run a separate thread which monitors the external system, and and then we can do a task reconfiguration. For offset management, in case of source connectors, we should try keeping a record of records that we are reading from the source systems by injecting this information in the offset map within the source records, so that Kafka Connect makes those offsets available when there's a restart. Using the offset storage reader, we can actually know the last process message belonging to each topic partition and resume reading records from the same position from the external system. Also, in case of certain systems like messaging queues, we have to acknowledge the records that we have received. For that, we should make use of commit record and commit methods to acknowledge those messages, so that the system doesn't send back duplicate messages to the connector, assuming they were not processed. In case of sync connectors, we should maintain offsets of the records that were actually written to the external system and return only those via pre-commit, as we have discussed before. Another alternative to offsets being maintained by Kafka Connect is to store the offsets in the external system. Like we can store the offsets in database tables. This helps us achieving exactly one semantics. As we are talking about offsets and how to manage them, it's important that we achieve the delivery semantics that is being expected in the use case. In some scenarios, like event-driven system, it's important for us to achieve exactly one semantics. Other use cases are a bit lenient, wherein processing duplicate is not much of a concern. Irrespective of this, we should avoid processing duplicate records and writing them to the external system or Kafka topics. And it's equally important not to miss any records while processing. We should maintain and commit offsets accurately, handle restarts by resuming from the same position where the connector task had left processing the records. While implementing connector tasks and dealing with the clients or API exposed by the external system, we might end up receiving errors. These errors might or might not be transient in nature. In case of transient errors, we should always try and retry the request made to the external system with some backoff, be it exponential or constant. It totally depends on the type of the system and its recommendations. So we should, by our own, we should retry the request that we are making if they are failing because of some transient exceptions. It totally okay. Also, we can make this behavior configurable by exposing configs related to retry behavior, such as max retry time or something like that, so that users have a hold over this behavior, and they can actually configure the time up till which the connector should retry maintaining connection or processing those requests again and again. Alternative to all of this is just to throw a retriable exception and to tell Kafka Connect to handle all the retries. In case of non-transient errors where we cannot continue processing records and also skip them, we can throw a connect exception with some informative trace that will end up killing the connector task. Also, it is good to fail the connector. It's good to fail fast and throw a config exception in the very start of the connector when the user provides invalid inputs to the connector. Some of the general recommendations will be not to swallow any exceptions and write the original exception while throwing it, so that it's easy for us to debug later by looking at the connect logs. While logging, we should make sure that we use the appropriate log levels and avoid polluting the logs. Logging every detail is not required. We can keep that at a trace level, and we should only use info and warn levels when connection is being established or some unusual or abrupt incident happens while processing the records. This is the obvious one. We should not log any sensitive data. When we encounter errors while processing records, we can either choose to fail the connector, log the error, and continue processing the subsequent records, or just ignore or move forward with the processing. Even this behavior can be made user configurable by exposing a config-like behavior on error, which can be configured to fail, log, or ignore. Logging can be done to some external source as well, so the implementation totally depends on our needs. Kafka Connect supports these data formats. Some of them are like Avro, JSON, string, and protobuf. And we can choose to use respective serializers and deserializers for respective formats. Important thing is that we should always try preserving the schema of the record. And to achieve this, we can embrace Avro type, which is JSON compatible, compact in nature, and also allows us to build records with complex data types and help preserving the schema at the same time. Defining and preserving schema helps us establish contracts between the system, make them more robust, allow us to decouple them into smaller components. Also, it helps us removing all the unnecessary effort that is required by the data science jobs involving cleaning, validation, and low-level managing of data. When a record is written to Kafka topic, we can choose to define the schema for both key and value components of the records. To improve the throughput of the connector, we should add multiple task support. That is very obvious. This may not make sense in few of the scenarios where an external system does not allow multiple clients to be open at the same time. Also prefer batching the records while writing them to the external system instead of writing them individually. Operations like acknowledging the records received from the external system can also be done in batches as well to avoid unnecessary network calls. If we talk about security, most of the clients require some of the basic authentications to establish connections with the external servers. In addition to that, we can add provision for proxy-based authentications and support for TSL and SSL in our connectors. In some cases, it would also require us to add NTLM and Kerberos-based authentication as well, but those are some niche requirements. It is also encouraged to add some pluggable credential provider classes wherein we can allow users to establish connections based on the credentials to log in with, especially in case of cloud-based services. Kind of emphasize more enough on writing unit tests that cover all possible inputs and scenarios to ensure everything works as intended and exposes any breaking change that is brought to the connectors we are implementing. I would recommend writing integration tests as well. There are some good examples for integration tests in the open source connectors like JDBC. Extensive system testing is also required, preferably in a production-like environment. Also, we can make use of Confluent's verification guide to conduct these system tests. To actually know how well the connector will perform in the production is to run the performance in a similar environment, which does not limit the performance of the connector. Make sure that we calculate the throughput at different task levels, and also check for any memory leaks while running the connector. So this is how we can get the performance of our connector. The documentation of connector is as important as the connector itself. So we should be very detailed and clear in the documentation. Mention the supported versions of the services and limitations of the connector. Provide a quick start that walks the users through a basic flow of configuring and running the connector. We can also refer the existing connector documentations available in Confluent Hub. Those are very nice examples. So some of the tips while implementing connectors for basic external systems. So these are some systems that we are going to discuss. While implementing source connectors for pull-based systems, we should make sure that we acknowledge all the records that we receive and appropriately configure the external system. Let's say we're dealing with some message queue. In this case, we should configure the acknowledgement deadline to a high enough value to allow connector to successfully process and acknowledge the records and avoid dealing with duplicates. Rest of the implementation should be forward. In case of sync connectors, the implementation becomes a bit tricky. Depending on the external system, we might have to buffer the records and flush them when there's a request being made by the external system. So for push-based systems, it would require us to start a separate thread and implement listeners if that's being expected. The thread would write records received to a shared buffer, which is accessible to the connector task. The task will then return these records in the poll method, and Kafka Connect will then write them to the respective topics. In case of sync connectors, the implement will be pretty simple. writing the records to the external system is pretty straightforward. We should preferably do that in batches. Databases are some of the most common systems for which we build connectors for. JDBC Sync Connector is a very good example as to how connectors should be implemented. The connector should correctly. Okay, so a few of the things that I want to discuss over here is we can add so many features to the connectors, and be data mapping, key handling, delete modes, and potential rights. We can discuss all this in detail, but then it's up to us what our needs are, and implement accordingly. So first of all, data mapping. The connector should correctly map the fields of the Kafka records to the columns in the database. Mapping primitive values are simple. For incompatible data types, we should write appropriate converters and then translate them and probably inject them as records into the data table. For defining primary keys while inserting records database, we can allow users to define fields present in the Kafka records key or value to be primary key of the row that is to be inserted into the table, or simply define Kafka record coordinates, that is the topic, partition, and offset, as the primary key of the record. Also, if we talk about delete mode that the JDBC connector supports, the connector should allow users to process the tombstone records that are present in the Kafka topic, and that simply means the records which have only records which have the Kafka value as null to be treated as delete request. And this just adds more flexibility to the connector. So if somebody wants to delete a certain record from the database table, they just have to insert a record with the with the appropriate primary key, be it the Kafka records coordinates, and then inject that as a Kafka value. Inject that as a record into Kafka topic with Kafka value as well. Sorry about the hiccups. In case of failure, we might end up processing a record more than once. So if we are treating each record in the Kafka topic as insert operation, we might end up writing multiple records into the database. So in such scenarios, if we treat each record in if we want to overcome this problem, we should choose the upsert operations, which is highly recommended, so that if the record is already present in the database table, we just update that particular record. The connector should also have the provision of creating tables in the database if they're not already present. And some of the records in the Kafka topic might not have the exact same schema as that of the table, right? So we should actually add the provision of schema evolution over there in our connector. In this case, we can also issue some alter commands so as to update the schema of the existing table and write those records into the table. So as I mentioned before, we should appropriately configure the messaging queues to avoid duplicate messages being processed by the connector, acknowledging the records received and converting these messages into Kafka records. The topic and subscription ID of the queue can go into the Kafka record header. There are a few of the mappings that I want to mention. And the message ID can be Kafka key, and the message body records value. So this is how we can, set the mapping between an actual message from the message queue to a Kafka record. So in case of incident management systems, it is important for us to achieve exactly one semantics. Retrying in case where the request failed, and appropriately logging a response in case of success and failures is very important. This helps us know where the problem lies, and probably we can go and rectify the connector and the problem wherever it is. In case of data lakes and data warehouses and other storage systems, when it comes to these systems, right, we can support multiple tasks and distribute and delegate work accordingly. so as to add more and more throughput to the connector and improve the connector's performance. We can introduce partitioners into the system that can help us determine how the data is to be written into the target system. It can be on the basis of Kafka records coordinates based on time, and also the value of the field present in the Kafka record key or value. The connector should also support consuming and writing data into different formats such as Avro, JSON, CSV, string or Parquet, whichever is needed in our use case. Object uploads can be done on the basis of record count and time-based rotations. This will determine as to how many records should be flushed in a single data lake object. We should always also avoid reprocessing the data that we have already discussed how to manage offsets and handle that. Building connectors for monitoring systems such as Datadog, Prometheus, CloudWatch, App Dynamics, and many other systems. We should try adhering to some of the standard metric formats like Open Census and Open Telemetry, and write these metrics to the Kafka. Treat these metrics as input. These formats as input, and then finally write them to the Kafka topic. We should try supporting different types of metrics as well. That is, maybe it can be in the form of gauges or histogram and whatever the external monitoring system, supports. It's important for us to commit records accurately and often to avoid corruption of data in the external system. For software development tools or other similar systems, we should try pulling data on the basis of time to avoid writing duplicate data into the Kafka topic. So every request that is made to the system, we update the time and get only the new records that have come into the system. Also, for some scenarios wherein this is not feasible, we can write some deduplication logic and identify the new records and then write them to the topic. One important point to keep in mind is that records being written to the Kafka topic partition are strict partition. So if you are expected to strictly maintain the order records, then we should have Kafka topic single partition, so that each record, all of the records are there in the same partition and they are ordered. In some of the general use cases, the external systems might have some sort of limitations, such as number of API calls that it can cater in a single minute or an hour or a day. In that case, we might have to do some sort of rate limiting in our connector, which helps us avoid exceeding those limits. Also, to apply transformations on the fly, we can make use of handy-dandy SMTs. There's some rich documentation present on Confluent website. Please check that out. As we build connectors, they will be subjected to changes as well. So be it in the form of improvements or features. My recommendation in this case will be to strive for backward compatibility so that people are able to frequently update the connector versions and use the latest features. While building the connector, we should also try supporting the oldest possible version of the service to cater a larger community. For cloud readiness in case of connectors, there are a couple of things that we should take care of. One is to ensure that Kafka Connect validation API is completely implemented, so as to ensure proper integrations with the Confluent Cloud UI. Any inputs provided by the user should be validated not only for the correctness but also for the completeness. Also, the connector should support injecting credentials via Apache Kafka config provider class. Finally, we should be ready to publish a connector once we are done building them. And we just need to check for restriction-free licensing in case the connector is supposed to be open source. Post that, we can submit the plugin via email with the Confluent Hub for additional information. So these are some of the links that I wanted to share with you guys. So these will be available in the platform, so you can take a look. So hope you guys had a great time. Now it's time for you to build some great connectors. Over to you, Lisa. Thanks.
Thanks, Fahad. That was very informative. So in addition to the resources that Fahad just mentioned, and by the way, all of those resources that Fahad showed on the links on the previous page are available in the resources tab as a URL. But on this page, I wanted to refer to the Confluent Verified Integrations Program webpage. It's a great resource, and it's recently been updated to reflect those additional steps that Fahad mentioned for cloud readiness. When you visit this page, go to the bottom to the Get Started panel, and you'll see these 6 updated URLs. There are 3 on the left for the gold level connector, which are those that adhere to the Kafka Connect API, and 3 on the right for the standard level. The process outlined here will help you self-verify and submit your connector for final verification with Confluent. At this point, we've come to the end of the presentation portion, so I want to say thank you to the audience for taking the time today, and also thank you, Fahad. We are ready to take any questions that you might have. Please refer to the Q&A panel at the bottom. Type in your questions, and I'll read those out for Fahad and for Jeff. And as you think of those questions, I wanted to leave this slide up, which will give you additional information. Question that I wanted to ask is directed toward Jeff. Jeff, welcome. Thanks for joining us. The question is the Kafka Connect cluster something that can be hosted by Confluent, or is it still something that has to be hosted by the customer?
So the answer to that question is both. Confluent Cloud does host Kafka Connect. The issue there is that we select the connectors that are included there, and there is a much broader collection of available connectors besides what's just on Confluent Cloud. So if the connector is available to you in Confluent Cloud, we're happy for you to use it. If you need to use another connector or a custom-built connector, then you need to host your own build of Kafka Connect.
The next question I'll direct toward Fahad. Fahad, can you give us some tips and tricks about connector debugging?
Yeah, totally. So in order to debug a connector, right? So I would recommend that, if you're testing the functionality and want to check whether everything is correct or not, I would recommend to write unit test cases and debug it. It's most welcome to write integration tests as well. You can use Docker containers and stuff so as to, test it against the external systems and debug it at the same time. So that shouldn't be an issue.
Jeff, is there a timeline published by Confluent that lists the connectors that will be supported in the future?
For Confluent Cloud, there is not a publicly accessible timeline. I do know that in the near term, we are looking to add the MongoDB source and sync connector to Confluent Cloud to provide connectivity between MongoDB Atlas and Confluent Cloud. And then we're going to follow that up with Snowflake. And then over the rest of the year, it's going to depend in terms of what we're hearing from the field and what our partners are providing.
Another one for you, Jeff. Do you suggest a way to mask the data using Kafka Connect?
So you can use single message transforms for that purpose for simple masking. For more complex masking, Confluent has Kafka Connect partners that offer this capability. The one that comes to mind is a company called Privitar. They provide a sync connector that consume data from a topic via that sync connector. But their trick is that they then mask or tokenize or encrypt that data in their system and then produce it back into a Kafka topic, which is then fully masked.
The next question, is there an HTTP sync connector available from the Confluent platform? And I don't know who to direct that question to, so either of you.
It's an easy question. Yes, it's on Confluent Hub.
Okay, thank you. Let's see. Next one is, maybe either of you again, if the poll method in the connector is grabbing a huge data set, the source record list grows too large and gives an out of memory. Do you have any recommendations, or is there an intermediate commit within the polling sequence?
I guess I'll answer this one. So if there are a lot of messages that are being captured by the connector and we are buffering them, in that case I guess we can configure the poll frequency as well, so as to how many times we should trigger the poll and process the records. Also probably what the other thing what we can do is we can stop pulling in messages from the external system till the time we process the records that are already there in the buffer. So that will help us. So that is one thing. The other, the last question regarding the HTTP SYNC connector. So so somebody asked that, is there a possibility of using it for Salesforce REST and APIs? So yes, we can use it for the simple use cases. So it totally depends upon the API we are supposed to request to. So yeah, HTTP SYNC connector can be used for Salesforce endpoints.
I had another one for you. Can connectors be written in other languages besides Java?
Okay, that's a tricky one. So I myself have tried it only in Java. I guess we can write them in Kotlin as well, but I'm not very sure. So probably I'll come back to this question again.
Any insight on that one?
Yeah.
Kafka Connectors is Java, so that's how you would do it. You could probably mock up something that obeys the same protocol, but I wouldn't recommend it.
Jeff, this one is for you. Is it possible to use HashiCorp Vault to secure Kafka connectors?
It's a great question. We're actually talking to HashiCorp to come up with something. Right now, I'm sure it's possible, but right now there's nothing off the shelf that does it.
Also for Jeff, is the MongoDB connector the Debezium one?
No, there are actually 3 MongoDB connectors available on the Confluent Hub. There's a community connector that was written by Hans-Peter Grossel. There's the Debezium connector, which is supported by Confluent. And then there's the MongoDB source and sync connector, which is written and supported by MongoDB. The one that we're talking about for, we just released the MongoDB source and sync. It appeared on the Hub mid-year last year, and it just went GA last quarter. And it's going to be available in Confluent Cloud this quarter.
The next question for Fahad. Do we have some connector development framework?
Yeah, so I guess that's called Kafka Connect. So yeah, we can use Kafka Connect for building the connectors. And probably, you can get the scaffold code as well by running simple Maven archetype commands. So yeah, that will help you build the connector. So yeah, Kafka Connector does.
Does Kafka Avro Connector support reading from multi-schema Avro topics with messages published using topic record name strategy? I'll open that up to either one of you.
I don't have the answer to that off the top of my head, but we can address it offline.
Yes, by the way, everybody, all your questions are recorded in the platform that we use with your email, so we can get back to you with an answer to your question later on. The next question is for Jeff. How is the Snowflake connector being written by Confluent different than the existing connector from Snowflake?
Confluent's not writing a Snowflake connector. We're talking about hosting the Snowflake provided connector in Confluent Cloud beginning in June.
The sync connector with X amount of topics, and then later decide to remove some of those topics from the sync is it possible to remove those topics from the consumer group?
I don't have the answer to that.
So even not very clear with the question, so probably we can come back to this.
Next question for Jeff. I've already written a connector and I'd like to post it on Confluent Hub. Is there a way I could do that?
So there are two ways to do it. There is you can submit a community connector via the submit a connector link on Confluent Hub, which will just get that, once it's packaged correctly, it'll be uploaded as an unsupported community connector. If you offer commercial support for your connector, if it connects into your data source and sink, and you offer support for that as well, then it's a candidate for our verified integrations program that Lisa discussed. So you can go read the documentation on the verified integrations program, have us verify it, or you can self-verify it. The result of that is basically a document and a checklist that shows how well your connector adheres to the best practices that we've provided as part of that verification program. And then once that verification is done, then it gets uploaded as a verified gold tagged connector.
Another one for you, Jeff. Is there a charge involved in using the existing connectors on Confluent Hub?
Most of the connectors on Confluent Hub are free of use, but there might be a few there that you will have to pay the provider of the connector to use. And it also depends on how you deploy it. So for example, I believe the Oracle Golden Gate connector is proprietary. So if you're using, you need an Oracle Golden Gate license to use that connector. MongoDB Atlas is a paid cloud service. So even though the connector is available open source to connect to Atlas, you need to be paying for an Atlas instance. And there are similar complications from connector to connector. In general, they're freely available.
The next question for Fahad. Does connector support sending data to multiple Kafka topics or vice versa?
Yes, it does. So in case of source connectors, it totally depends on how we frame the source records, right? So whenever we are pulling data from the external system, we can just choose to, when we are translating that particular data into the source records that will eventually go into the Kafka topic, we can choose to define the topic and partition for that record, and it will be written into the same topic partition. So yeah, we can do that, and the other way around as well.
Do you know if the Debezium Postgres connector works with AWS RDS?
That's a question about the Debezium connector. I don't know off the top of my head.
This connector will work with RDS. You just have to provide your Postgres URL. That should be fine.
Is the Confluent Cloud flexible on the connector configurations? Are there any limitations in flexibility, such as the S3 connector?
So that's a great question. The Confluent Cloud team decides which connect configurations to expose to the end user, and then also decides which connect configurations to automate that are specific to Confluent Cloud. And this is to make a better user experience. So, for example, Confluent Cloud knows where your Kafka cluster is, and so it will plug that in for you. And in a lot of instances, it knows where the target is as well. So there's a specific decision that the Confluent Cloud team makes in terms of how much of that can connect configuration to expose to the end user. And that's going to vary by connector. And that's a big part of why right now we're choosing on a connector by connector basis which ones to host in cloud.
is, what are the parameters to consider to handle connector memory? Who wants to take that one?
I guess, okay, so, yeah, Jeff, go ahead.
No, go ahead. I was just going to say, I was just going to say I need to take that offline. So if you have answers off the top of your head, go ahead.
Okay. Yeah, so for handling connector memory, I guess there are no parameters as such, just that, if you're buffering records, yes, you can choose to, expose some configuration so as to limit the buffer. And yeah, this is how we can implement it. So, you can limit that buffer, allow the connector to drain all the records to the topic or, the external system, and then, clean up the stuff. So it's how you can make the connector configurable.
Have a little bit of time left. Is there a database for Kafka? I'm not sure I understand, Satish, your question. Are there existing database Kafka connectors providing the below features, data filtering, support for custom queries, change data capture to get only delta data?
So yes, I would, this is something that is going to vary by connector. Different connectors are going to do this in different ways, and it's going to depend on, the query language in the database and how you connect and capture the change data capture data. For example, looking at MongoDB again, the Debezium change data capture connector from MongoDB looks at the MongoDB oplog and just captures, the replication data from Mongo. Whereas the MongoDB connector lets you specify an aggregation pipeline. An aggregation pipeline is basically a data integration job against change data in Mongo. And there's a whole language that MongoDB provides for defining that aggregation pipeline. You can plug that string, a query or an instance of that pipeline into the connector, and then the connector will execute that pipeline and then give you the result for Kafka. So that's going to vary connector by connector. So you need to look at what each individual connector supports in terms of these capabilities.
And does Confluent support JMS and MQ source sync connectors? And do you know if it's free?
I would take a look at Confluent Hub for that. I believe the answer is yes. Yeah, there's a JMS sync and source that are Confluent supported, and then MQ. There's RabbitMQ and MQTT and IBM MQ and ActiveMQ connectors that are available.
Jeff, is that URL confluent.io/hub? I think it is.
Yep, that's correct.
Right. Here's another one. Can we use connect logs to have a good experience with the connectors? And can we also use it in debugging?
Yeah.
Lisa, can you ask the question again?
Can we use connect logs for a better experience with connectors, and can we also use it for debugging? And the answer that Jeff provided was yes, we can.
Yeah, totally. So we can use it debugging as well. Just that you should not pollute the logs with logging everything. So just the important thing should be logged. Then it will be helpful for you. And plus, whatever operations that are being performed, from the external system, probably we can, log the response as well, so as to give us deeper insights of the data that is, flowing.
With that, I'm going to wrap it up. I'd like to thank everybody for attending today And I'd like to, again, refer you to the resources tab. It has a lot of the URLs that Fahad talked about. It also has the PDF of the slides today. And you can also, using one of the buttons below, you can share this with some of your colleagues if you think they'll find this of interest. And you can always come back later today. I think it's maybe late in the afternoon or tomorrow at the same URL, and you can listen to the recording and send your colleagues to the recording as well. Thank you very much, Fahad, and thank you very much, Jeff. I hope everybody has a great day.